Hello everyone. My name is Gajanan Navle, and this is my project for Module 3. Today I'm going to present a project dissection and a schema design for platform Zerodha Kite. I chose Zerodha because it is the biggest stock trading platform in India. It handles over millions of transactions every day, and this makes it a perfect example to study how large-scale database should be designed. So, in this presentation, I will cover three main things. First is the features of this platform. Second is the real-world problems it solves. And third is the database schema and ER diagram I have designed for it. So let's start with first section, which is platform understanding. Platform understanding. I have chosen Zerodha Kite because it is India's #1 trading platform. I chose this because it deals with real money and millions of transactions. So the database design has to be perfect. Next is core features and functionalities. So my research identified the main things the user does on this app. So first is user profile. This is where users' personal details and Demat account info are stored. Next is the watch list. So this is the list where users can save the stocks they want to track, like their favorite stocks. Next is instruments. So these are the actual stocks or indices like Reliance, Tata Motors, Nifty 50 that people trade. Next is orders. So this is the most important feature. It allows users to buy or sell stocks. Next is portfolio. So this shows the user what they currently own and their profit and losses. And next is bids. So this shows the live market depth, like who is buying and selling at what price. So the next point is problem solving analysis. So in this section, I will explain the real world problems that existed in market and how Zerodha Kite solved them. So problem one was high cost for small investors. So the challenge was before Zerodha, traditional brokers charge percent-based fees like 0.3%, 0.5%. So if you traded a large amount, you paid a huge fees. And this made trading very expensive for normal people. So for this, the Kite solution was they introduce a discount brokerage model. So they charge a zero brokerage for long-term investment and a flat fee of rupees 20 for intraday trades. So this made the market accessible to everyone. Problem two was fragmented and slow technology. So the challenge was traders used to struggle with bad software. They had to install a heavy desktop app for trading, then go to a website to see their back office reports, and then use another tool for charts. So it was slow and confusing. So Kite brought the solution, which is they built a Kite Web, so which is a single super fast website. So it combines trading, charting, and portfolio in all in one place. So third problem was monitoring prices. So a normal person cannot sit in front of a computer from 3 a.m. to 9 p.m. to watch stocks prices. So if they wanted to buy a stock at a lower price, they missed the chance. So the Kite solution was they created GTT, which is good till triggered order. This allows users to set a trigger like buy Reliance if it drops to 2000 rupees, and this order stays active for 1 year. So it works like a robot watching the market for you. Uh, Next is the next section is case study development. So here in this section, we will break down specific difficulties that users face and the specific features that solved it. So first difficulty was that the stock market has thousands of stocks. So it was overwhelming for people to find out correct stocks from list of thousands of stocks in the market. So to solve this, Kite added the watchlist feature. So this feature allowed users to create a personalized list of 10 or 20 stocks that they care about. So it filters out the huge noise. Second difficulty was most people can't sit glued to their screen from 9 a.m. to 3 p.m. Watching stock prices. So when a stock dips to their ideal buy price, they often miss a chance to buy it. So to solve this, Kite added GTT, good till triggered orders. So it was a smart way to automate the trades. A user can now set a long term trigger, for example, buy 100 shares of Reliance if the price hits rupees 2000. So GTT will do it on your behalf and your orders stay active up to 1 year, ready to execute the moment you hit your trigger. Next problem was that people didn't know if they were making profit or loss from their investments. So to solve this, Kite added the portfolio screen. So this provides a simple one-glance summary of holdings, uh, their current value, the profit and loss. This screen automatically calculates the average buy of all your stocks and compares it to current market price to show you exact profit or loss in real time. So, and users no more need to manually track their investment in spreadsheet. So, next difficulty was that traders running multi-leg strategies like three-leg or four-leg options setup often struggle with placing each order manually. It's time-consuming and prone to errors. So, to solve this, Zerodha introduced the basket feature. So, it allowed users to group multiple orders into single basket and execute it in one click. So just build your strategy, add all legs to one basket, and execute them with single click, solving the problem of manual one by one execution. So the next section is schema design and detailed description. So this is a technical part of our project. So I have designed the database schema to support all the features I just mentioned. So I will explain each entity, table, and its attributes columns. So first table is a user entity. So this table stores personal information of the trader, which consists user ID column, which is primary key. So this is unique ID for every user. Example AB1234, and it is primary key because it uniquely identifies the record. Next is a username. So this is the name user uses to log in. Third is email ID of the user. Fourth is full name, the legal name of user as per PAN ID. Fourth is DMAT ID. So this is 16-digit official ID that links to user to the central depository like CDSL or NSDL. Second table is instrument entity. So this is the master list of all tradable items. So in finance, an instrument refers to a tradable asset. So we are calling it instrument because it contains stocks, features, options, and indices. So under it, first column is instrument ID, which is primary key. So it is a unique ID for every stock. For example, 256265. Second is trading symbol. So this is short name we see on the screen like Reliance or TCS. Next is exchange. So this is to know if the stock is listed on NSE or BSE. And next is full name. So this is a complete name of company. So the third table is watchlist entity. So this table saves the list created by the user. So it has a first column called a watchlist ID, which is a primary key. So it is unique ID for a watchlist. Second is user ID, which is foreign key. So this links the watchlist to the user who created it. So third is watchlist name. So the name given by user like my favorites or bank stocks, etc., etc. Fourth table is watch list item entity. So this is junction table. So this is a table used to connect a watch list and instruments. So it has a first column called watch list item ID. So it's unique ID for this row. Next is watch list ID, which is foreign ID, foreign key. So it connects the watch list table. So it connects to the watch list table. Next is instrument ID, which is foreign key. So it connects to the instrument table. And why do we need this? Because one watch list has many stocks. So one stock can be in many watch lists, like many to many relationships. Fifth table is order entity. So this is most critical table. So it acts like a logbook or a history books. It records every single action. So it has first column called order ID, which is primary key. So it is unique ID for every order. Second is user ID, which is foreign key. So it links to the user who placed the order. Third is instrument ID, which is foreign key. So it links to the stock being traded. Fourth is transaction type. This tells you if it is a buy or sell. Next is product type. So this is very important. So CNC means cash and carry, which means this is a long-term investment. And on the other hand, MIS means the intraday short-term trade. So this column decide if the stock goes to portfolio or not. Next is quantity, the number of shares. Next is price, the price at which user wants to buy. And next column is status. So this shows if the order is open, executed, or cancelled. So next table is a holding entity. So this table represents the user's portfolio. So it shows what they own right now. So it has first column called holding ID. So it is unique ID for holding. Second is user ID, which is for foreign key. So this links to the owner of the stocks. Third is instrument ID, which is foreign key. This links to the stock to the user owns. Next is quantity. So the total number of shares available in their account. And next is average buy price. So this is average price of shares user bought. This is used to calculate the profit or loss. So the next section is rational and relationships. So in this section, I will explain you the logic behind connections and why I have designed the tables this way. So A is the relationships and integrity constraints. So this is how the table connects. First is user. So user connects to the order on one-to-many relation. So one user can place many orders. This is why order table has the user ID. Next is user to holding. So user connects to the holding on a one-to-many relationship. One user can own many different stocks. Third is the instrument to orders. So instrument connects to the orders on one-to-many. One stock like Reliance appears in thousands of different orders from different people. Next is watch list to instruments. So watch list connect to the instruments on many-to-many relationship. As explained before, we use the watchlist item table to bridge this connection. So B is core business logic rational. So this explains the business reasons behind my design choices. So first is the instrument as a single source of truth. So why we use an instrument table? So instead of writing a full name like Reliance Industries Limited inside every single order, we just use the instrument ID. This saves a huge amount of storage space. Also, if a company changes its name, we only have to update it in one place, the instrument table. So instead of updating million past orders. The next is orders and holding separation. So this is the most important design choice I made by separating order table and holding table. So here the order table acts like a history book. So it records every single time a user tries to buy or sell. So we keep this data forever for records and never delete. On the other hand, holding table acts like a current summary. So it simply shows what the user wants right now. Now why we separate these two? The reason is speed. So when a user opens their app, they want to see their portfolio instantly. So if the database had to calculate their balance by reading through 5 years of past orders every single time, the app would have been very slow. So by having a separate holding table, the app can load the portfolio instantly. So that's why we separate them. So next is ER diagram. So as you can see, this is the entity relationship diagram that visualizes schema I have explained above. So it shows the user in the center connected to their orders, watch list and holdings. So you can see here in this diagram, there is a user table which is connected to watch list table, which is then connected to holding table, and which is also connected to the orders table, and orders table connected to the instrument table, which is connected to the watch list item. So, and watch list item is also connected to the watch list table. Now coming to the conclusion, so in this case study we delve into the design of Zerodha Kite's schema and its entity relationship diagram. So Zerodha has revolutionized the Indian financial landscape by solving key user problems like high cost or fragmented technology. The platform's intricate data model consisting of entities like user, instrument, order, holding and watch list forms the foundation of its seamless and high-speed functionality. By understanding this schema, we gain insight into how Kite effectively manages the complexities of real-time financial transactions, user portfolio management, and data integrity, contributing to its widespread popularity and continued growth in the world of financial technology. Thank you.